So it's time to take a look at the overloaded subscript operator. And in this example, there are two versions of an overloaded subscript operator. So this is the use. We have a function that we would like to implement named copy. And it takes two parameters. One is the destination and another one is the source. And we're defining this copy function for the class name myDoubleArray. So apparently double array contains some sort of storage for double values. And when we use, this is the use of the subscript operator right here. When it's used on the right hand side, of course this does not require, this only requires an R value, a right hand side value, so it doesn't have to be modifiable. That's why compiler will choose a constant version of this, and in this case this operator, part of myDoubleArray, will return a double, right? So this gets resolved when the operator is called, gets resolved to a double. On the other hand, we have the left hand side value, L value, right here, and this sub-expression using the square brackets will resolve itself to use the non-constant version of the overloaded operator. So typically you implement both, and this one returns a reference to a double. So then this copy of the double returned by the right hand side will be assigned to an object specified by the reference to a double returned by this non-constant version of the operator, the subscript operator version. So that's the idea of how you would approach to make sure that your objects can be used with subscript notation on both sides of the assignment. Now, in case of the string, this Java-like string that we design, in this example, we really don't need the non-constant version because we treat our class as non-modifiable, immutable, constant string. So we can just try the constant version of this operator. So let's give an example of the syntax. So because subscript operator requires an L value, we have to implement these operators as member functions of our class. So here, this is an example. We can just add them like this. And I keep the non-constant version of the subscript commented out just to indicate that we could have it, but the nature of our string class that it's just read-only. So we really don't need something that could be used to modify characters using the subscript inside our class. So then let's try possible implementation. So I'll just scroll down to the bottom of my file right here and just try to do this. And again, if I would consider implementing this version, non-constant version, of course I would use a function body like this. So this would be the name of the function, this would be the subscript, and then there will be an implementation right here. Now the constant version of to be used on the right hand side is here. So we take the subscript index, which I am expecting only positive values for this index no negative values. That's why I use size type as a type for my index. That's the name of the member function of our string class, operator, square brackets like this. And all we have to do, we can just, again, as we did with most of our operator implementations, we just find the way to delegate this to member functions. But in my case, I delegate this to string view, which so the string view that we keep as a member of our string implementation already provides the square bracket index overloaded operator. So this again becomes quite trivial. And I looked it up in the documentation for string view. String view subscript operator returns a reference to a constant character. Okay, so that's why I'm duplicating this exactly as this is done by the string view. So let's see, let's try testing this code. So this is our main function which we're using to do all of this testing. So let's plug it in somewhere, and what I'm copying and pasting here is using the index 0 and also going to selected string length -1, which should be the index of the last character, and we'll be printing the first character and the last character of the selected string, which happens to be whatever is returned from this call. So let's just print some sort of caption right here and say testing subscript operator. Okay, and so we should see the last, the first, right? So this is first character, and this will be last character in our output. So let's do this quick test on the subscript operator. Let's just build this and run this code. So here this is my display of testing subscript operator. So we had the string version that was returned here is right left. Right, so this was the right left. So this is right left that was produced by combining right with left in that order. And the first character, of course, is character R, and the last character is character T. So our subscript operator is working well with strings.